Now let us start the new chapter of rational numbers of class 8. Now rational numbers are the numbers which are in the form of p by q. By looking p by q we can tell these are the numbers little bit like fractions only. Okay, here p numerator, q denominator only, but where p and q are integers. Very important, integers. Integers will have positive as well as negative also. And one more condition is there, q not equal to 0. That means denominator should not be 0. These numbers are called rational numbers. Once again, the numbers which are in the form of p by q. P by q means we'll think these are like fractions only, no. But p and q, both the numbers should belongs to integers. This is your first condition. Q not equal to 0 means denominator should not be 0. Such type of numbers are called rational numbers. Examples 6 by 7, minus 5 by 8, minus 10 by 9. Since they said integers, we will have negative numbers also. So these are the rational numbers of examples. So now let us start properties of rational numbers. First we are learning all the 4 properties regarding the addition. So first property is nothing but closure. What is the meaning of closure means? When we add any 2 numbers, that answer should present in that particular set only. Suppose let us take integers. 1 plus 2, 3. 3 belongs to integers only. Closure means closed. It should be present in the closed box only. Same way, for all, a comma b belongs to q. Rational numbers will indicate with the capital letter q. So, a will be in the form of p by q. B will be in the form of also p by q. When we add 2 p by q rational numbers, that answer also should belongs to the rational number only. Example, take your own examples. 3 by 5, 7 by 3. We are adding, no? So 3 by 5 plus 7 by 3 in 7th standard we know fractions addition. Denominators multiply. 5 3s are 15, 3 3s are 9, 7 5s are 35. 35 plus 9 is 44 by 15. This is also in the form of p by q only. So closure is satisfied because when we add 2 rational numbers we are getting rational number only. So rational number definitely in the form of q set only. So closure is satisfied. When we add 2 rationals, answer should be rational. Simple. When we add 2 rational numbers, answer should be rational number. What is the process of adding? Like fractions only. 5 3s are 15, 3 3s are 9, 7 5s are 35, 9 plus 35 is 44 by 15. So closure is satisfied. Next comes to commutative. Commutative is nothing but 1 plus 2 is also 3, 2 plus 1 is also 3. So both the sides reverse also we should add. So a plus b is equal to b plus a. For all a comma b belongs to which set? Rational number set. So now here also take your own example. 2 by 3, 4 by 5. How we will add this set fraction? Same way that side also. 3 5s are 15, 2 5s are 10, 4 3s are 12. 10 plus 12 how much? 22 by 15. Now comes to RHS. 5 3s are 15, 4 3s are 12, 2 5s are 10. 12 plus 10 how much? 22 by 15. LHS equal to RHS. When both the sides answers are same, then commutative is satisfied. If it is numbers, we can easily tell 1 plus 2, 3, 2 plus 1, 3. Same way in rational numbers also, when we add 2 rational numbers, on reverse order also we should get same answers. Then only commutative is satisfied. First is closure, second is commutative. Next, so third property is existence of identity. For all a belongs to q, a plus 0 is equal to a is equal to 0 plus a. A is nothing but rational number. So let us take example 2 by 3 plus 0 is equal to 2 by 3. 2 by 3 is equal to 0 plus 2 by 3. One more example is minus 6 by 7 plus 0 is equal to minus 6 by 7. Minus 6 by 7 is equal to 0 plus minus 6 by 7. Generally 2 plus 0 2 we will tell no in lower class. So 0 is known as additive. For any number if you add 0 we will get the same number. That is the simple concept. For any rational number if you add 0 we will get the same rational number. So 0 is known as additive identity. Now come to next one, existence of inverse. Since we are in rational numbers, P and Q are an integer set, no? So if one positive rational number is there, that negative rational number also will be present. That only. For all A belongs to Q, minus A is also belongs to Q. Since this is integers, no, we know plus 1 is there means minus 1 also. Same way, example, if plus 2 by 3 is there, additive inverse is minus 2 by 3. Additive inverse is nothing but changing the sign. Plus means minus, minus means plus. When you add two rational numbers, 1 plus 2 by 3 minus 2 by 3 will get cancelled. We should get answer 0. If you are getting 0 when we add two rational number means they both are additive inverse to each other. 2 by 3 will be for minus 2 by 3, minus 2 by 3 for 2 by 3. So now last property of addition is associative. For all A, B, C belongs to Q. Commutative we have taken 2. In associative we will take 3. A, B, C are 3 rational numbers. This is your associative property. A plus B plus C is equal to A plus B plus C. When we read also we should show the variation. A plus B plus C is equal to A plus B plus C. Now let us take example. 2 by 4, let us take 2 by 4 as A, 5 by 4 as B, 7 by 4 as C. Now write the associative property. A place write 2 by 4, B place write 5 by 4, C place 7 by 4. Same. Now if you observe denominators are same. So directly add the numerators. 2 plus 5 how much? 7. 7 plus 7, 14. So LHS value is 14 by 4. RHS 5 plus 7, 12. 12 plus 2, 14 by 4. If you observe LHS is equal to RHS, therefore associative property is satisfied. So now next binary operation is subtraction. So now again first property is closure. For all A comma B belongs to Q, A minus B also belongs to Q. Example 6 by 7 and 8 by 7. A minus B no. So 6 by 7 minus 8 by 7. Anyhow we know fraction subtractions. Denominators are same. So 6 minus 8. 6 minus 8 is minus 2. If you don't know 8 minus 6 plus 2 means 6 minus 8 will be minus 2 by 7. We already know P by Q are coming from integers. So integers will have negative numbers also. So this will belongs to rational numbers. Therefore closure is satisfied. Now come to next second property, commutative. For all A comma B belongs to Q, A minus B not equal to B minus A. Now take A value as 3 by 5, B value as 2 by 5. Substitute 3 by 5 minus 2 by 5, 2 by 5 minus 3 by 5. Now since denominators are same, 3 minus 2 is 1, whereas 2 minus 3 is minus 1. So plus 1 by 5 is not equal to minus 1 by 5. So commutative property is not satisfied. If commutative is not satisfied, associative is also not satisfied. This is your associative identity. A minus B minus C not equal to A minus B minus C. So now take third binary operation, multiplication. First one is closure. When we multiply two rational numbers, we should get the rational number. So closure property is for all a comma b belongs to q, a into b belongs to q. Example 2 by 3 comma 6 by 7. 2 by 3 into 6 by 7, 2 6 are 12, 3 7s are 21. So this is belongs to rational number. In multiplication of rational number, the only thing you should learn tables. Only thing you learn tables, then everything is easy. So closure is satisfied. When we multiply two numbers or two rational numbers, we are getting a rational number. So closure is satisfied. Coming to second property, commutative property. For all a comma b belongs to q, a into b is equal to b into a. Now let us take one example, minus 9 by 4 comma 2 by 8. Minus 9 by 4 is a, 2 by 8 is b. Multiply, plus into minus, minus 9 2s are 18, 4 8s are 30. This is your LHS. Now go to RHS. 2 by 8 into minus 9 by 4. Plus into minus, minus 2 9s are 18, 8 4s are 32. LHS is equal to RHS. So therefore commutative is satisfied. Now in multiplication, closure is also satisfied. Commutative property is also satisfied. Now come to third property, associative. In associative, we will take three rational numbers. For all a comma b comma c belongs to q, a into b into c is equal to a into b into c. Now a value, let us take 2 by 3, b value is 5 by 4, c value is minus 8 by 2. We can take your own examples because if you know multiplication, this is easy only. So now a place write 2 by 3, b place you write 5 by 4, c place at minus 8 by 2. This is your LHS. So first multiply the terms which are in the brackets. 2 5s are 10, 3 4s are 12. Here multiplication also numerator, numerator, denominator, denominator. Now what values we got? 10 by 12. Multiply, plus into minus, minus, 10 8s are 80, 12 2s are 24. This is your LHS. Now comes to RHS. A value is 2 by 3, B value is 5 by 4, C value is minus 8 by 2. Plus into minus, minus, 5 8s are 40, 4 2s are 8. Plus into minus, minus, 2 into 40 is 80. LH is equal to RHS. Associative is satisfied. Now fourth property is multiplication by 1. For all a belongs to q, that means any rational number, when you multiply by 1, we will get the same rational number. Example, minus 6 by 7 into 1 is equal to minus 6 by 7. Generally we know one table, from primary we are learning, any number multiplied by 1 will give the same number. So minus 6 by 7 into 1 is equal to minus 6 by 7. Therefore, 1 is the multiplicative identity. Any rational number, if you multiply by 1, will get the same number. So 1 is the multiplicative identity. Now comes to fifth property, multiplicative inverse. For all a belongs to q, 1 by a also belongs to q. Any rational number will have the reverse of that number. So every rational number will have the inverse of that number. So a belongs to q means 1 by a also belongs to q. When we multiply rational number and its reciprocal, we will get the value 1. Now let us take example, minus 6 by 7. What is the minus 6 by 7 multiplicative inverse means? Minus 7 by 6. One more important, in multiplicative inverse, only the rational number will interchange, not the sign. So whatever signs are there, as it is, we will write in the answer. Minus 6 by 7 will become minus 7 by 6. Multiply the both, we will get the answer 1. Therefore, minus 7 by 6 is additive inverse of minus 6 by 7. Minus 6 by 7 is the multiplicative inverse of minus 7 by 6. Therefore, multiplicative inverse are reciprocals to each other. Now comes to last property, multiplication by 0. For all a belongs to q, a into 0 is equal to 0. Any rational number, if you multiply by 0, the answer is 0. So, let us take example minus 100 by 9 into 0 is equal to 0. Any number multiplied by 0 is 0 only. Now last binary operation is division. First you take closure. For all a comma b belongs to q, a divided by b belongs to q. So now let us take one rational number 2 by 3. The other one has 6 by any numbers you can take 6 by 8. 2 by 3 divided by 6 by 8. First rational number write as it is 2 by 3. Division opposite sign is multiplication. 6 by 8 will be reversed as 8 by 6. Now multiply. 2 8s are 16. 3 6 are 18. So closure property is satisfied because when we multiply or when we divide any two rational numbers, we are getting a rational number only. So closure is satisfied. Now very important property, commutative and associative is not satisfied. A divided by B not equal to B divided by A. If commutative is not satisfied, associative also will not satisfy. A divided by B divided by C is not equal to A divided by B divided C. So commutative and associative is not satisfied under division. Now division by 0. So for all A belongs to Q, any rational number, if you divide by 0, the value is not defined. Very important, any rational number if you divide by 0, the answer is not defined. So division by 0, whatever number if you divide by 0, the answer is not defined. Division of 0 by A. So 0 if you divide by any rational number, answer is 0. Students will get confused here only. Any number divided by 0 is not defined. 0 by something is 0. So A by 0 is not defined. 0 by A is 0. Division by 1. Any rational number if you divide by 1 will get the same rational. How we will get when we multiply? Same way. Any rational number if you divide by 1 will get the same rational number. Division by minus 1. For all A belongs to Q, any rational number divided by minus 1 will give you minus A. So these are the 4 division rules. Once again, division by 0. Any rational number divided by 0 is not defined. Division of 0 by A. 0 by something is 0. Division by 1. Any rational number if you divide by 1 will get the same rational number. Division by minus 1. Any rational number if you divide by minus 1 will get minus A. So now start exercise 1. Fourth problem. Multiply 2 by 11 by the reciprocal of minus 5 by 14. So first write 2 by 11 as it is. Multiply reciprocal of minus 5 by 14. So minus sign will be as it is. 5 by 14 will become 14 by 5. Plus into minus, minus. 2 14s are 28. 11 5s are 55. Once again multiply 2 by 11 by the reciprocal of minus 5 by 14. So 2 by 11 as it is, multiplied reciprocal of minus 5 by 14. So in reciprocal minus will become as it is. 5 by 14 will become 14 by 5. Plus into minus minus. 2 14s are 28. 11 5s are 55. Now comes to 8th problem. Subtract 3 by 4 from 1 by 3. In subtraction, from after rational number will come first. 3 by 4 we have to subtract from where? 1 by 3. So this 1 by 3 we have to write first. 1 by 3 minus 3 by 4. Multiply. 3 4s are 12. 1 4s are 4. 3 3s are 9. 4 minus 9 is minus 5 by 12. So this is the answer. Now ninth one, what number should be added to minus 5 by 8 so as to get minus 3 by 2? What number we don't know, so take as x. Added means plus. What is the second rational number? Minus 5 by 8. To get is equal to minus 3 by 2. Convert the question into this equation. What number? We don't know, so we write it as x. Add means plus. What is the second rational number? Minus 5 by 8. To get means is equal to minus 3 by 2. Now plus into minus, minus 5 by 8 is equal to minus 3 by 2. Minus 5 by 8 when it comes to RHS it becomes plus 5 by 8. Minus 5 by 8 when it comes to opposite side it becomes plus 5 by 8. 8 2s are 16. 5 2s are 10. 3 8s are 24. 10 minus 24 is minus 14 by 16. What number to be added means x equal to minus 14 by 16 is to be added. So now next topic is representation of a rational number on number line. For example, 3 by 5 is a rational number. So from 0 to 1, what is the denominator here? 5. So divide 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5. Last one will be 1. 5 by 5 no? So 1. So your 3 by 5 is lying between 0 and 1. So condition is if numerator is less than denominator, definitely value lies between 0 and 1. 3 by 5. From 0 to 1, each part you divide by 5. 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. Last one will be 1. 3 by 5 will lies between 0 and 1. Same example, you take reverse 5 by 3. Here numerator is greater than denominator. So 0 by 3, 1 by 3, 2 by 3, 3 by 3 is 1. Next continue. 4 by 3, 5 by 3, 6 by 3 is nothing but 2. So the 5 by 3 is lying after 1. So numerator is greater than denominator means value lies after 1. So third problem is find 5 rational numbers between 1 and 2. Since they gave here 5, divide 0 to 1 between divided by 6 because then only we will get 5 parts. 0 by 6, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6 is 1. After 6 by 6 continue 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, 12 by 6 which is 2. So between 1 and 2 we have 5 rational numbers. So this is your solution. Now one more problem is find 12 rational numbers between minus 1 and 2. Write minus 1 by 10 because your decimals will start minus 1 by 10 if you divide by 10. After writing dividing 10, write integers decreasing order minus 1, 0, 1, 2. They are asking you to write between minus 1 and 2. When we divide by 10 we are getting 2 only. So what we have to do is again minus 1 by 10 multiply 10 by 10 plus into minus minus 1 tens are 10, 10 tens are 100. So minus 10 by 100. 2 tens are 20, 10 tens are 100. So between minus 10 by 100 to 20 by 100 we have many rational numbers. From that any 12 rational numbers is our answer. So now last topic of rational numbers, decimal representation of a rational number. We have two types of decimals, that is terminating and non-terminating. Terminator means when we divide a two rational number, remainder is 0, quotient will be 0.67, which is a finite. That means we can able to see the last decimal value. Whereas non-terminating means remainder is not 0, quotient will be so on repeating 36, 36, 36, so on. That so on repeating is known as only non-terminating. Once again, terminating means when we divide a rational number, we get remainder 0. Example, quotient is 0.67. After decimal, you can tell what are the end values, 7. But whereas in non-terminating, remainder is not 0. Quotient, let us take example, 0.3636, so on. That 3636 so on is known as non-terminating. And in non-terminating, we have two types. One is pure non-terminating, other one is mixed non-terminating. In pure non-terminating, 0.36 bar. After decimal point, all the values will repeat. Bar indicates repeat. So after decimal, if all values are repeating, that is pure. After decimal, only few values are repeating, mixed. So pure means after decimal, all values will repeat. Whereas in mixed, after decimal, only few values will repeat. Now we have to know about what is period and what is periodicity. Period is nothing but what numbers are repeating. Here what numbers are repeating? 3, 6. So period is 3, 6. How many are repeating? 2 values. So how many values are repeating is known as periodicity. What are that values is known as period. So same here also. Period is nothing but how many values are repeating? 5, 4, 3. So what are the values? 5, 4, 3. What are the values are repeating is known as period. How many values are repeating is known as periodicity. So periodicity is 3 here. Now for pure non-terminating, we have A dot BC bar. We have taken here 0.36 bar now. So A 0 indicates A, 3 for B, 6 for C. If our decimals prolong, alphabets also we have to prolong. A dot BC bar is equal to ABC minus, before decimal point, what value is there? A, that we have to subtract. How we have written 99 means, under the bar how many values are there, that many 9s we have to write. Here under the bar 2 values, no? So 2 9s we have written. This is the formula for pure non-terminating. Now comes to mixed. A dot BCDE bar is equal to, same here also ABCDE full we will write, minus whatever values are not there under the bar we have to write, even though it is after also, AB by, now after decimal how many are under the bar? 3. So for each one 3 9s. After decimal which is not under the bar, one value, no? So for that 0. So this is the formula for mixed non-terminating decimals. Now if 2 by 5 of a number exceeds 1 by 7th of the same number by 36, find the number. Solution, let us consider that number be x. 2 by 5 of a number means 2 by 5x exceeds is equal to 1 by 7th of the same number, 1 by 7x. By how much it is exceeding? Plus, exceed means more, plus 36. So bring this 1 by 7x to LHS, it become minus 1 by 7x. So in this both take x common. 2 by 5 minus 1 by 7. 5 7s are 35. 2 7s are 14. 5 1s are 5. 14 minus 5 is 9. 9x by 35 is equal to 36. X equal to 36 into 9 by 35 will be 35 by 9. 9 4s are 36. X value is 140. Seventh problem. 7 2 by 3 meters cloth is 12 rupees 3 by 4. So 72 by 3 meters cloth if you purchase, the amount you should pay is 12 3 by 4 rupees. Suppose if you purchase 1 meter cloth, how much rupees we have to purchase? So how much we have to purchase, how much we have to pay, we don't know. So let us take it as x. So we have to do cross multiplication. 7 2 by 3 into x is equal to 12 3 by 4 into 1. 7 2 by 3 you have to convert into mixed fraction into improper fraction. How? 7 3s are 21. 21 plus 2, 23 by 3 into x is equal to 12 4s are 48. 48 plus 3, 51 by 4. X equal to 51 by 4 into 23 by 3 will be reversed as 3 by 23. 51 3s are 153. 4 23s are 92. So 1 meter cloth is 153 by 92 rupees. So this is your 7th problem. Now 8th one, what number should minus 33 by 16 be divided to get minus 11 by 4? So now let us consider what number we don't know. So take as x. Minus 33 by 16 should be divided with what number we don't know. So take as x is equal to minus 11 by 4. Minus 33 by 16 is a first rational number, no? So write as it is. Now denominator x, do cross multiplication. So this x is in left hand side, will go to right hand side. Now right hand side minus 11 by 4. When it comes to a left hand side, it will be reverse. So here 11 by 4 will become 4 by 11. Now 4 1s are 4 4s are 11 1s are 11 3s are. So your x value is 3 by 4. Minus into minus plus. So your x value is 3 by 4. What number to be divided means 3 by 4 should be divided. So the ninth problem is 10.363636 so on. We should write it in the simplest form p by q and we have to find p plus q. Now comes to the solution. 10.3636 so on. We write it as 10.36 bar. After decimal both the values are repeating. So it is known as pure non-terminating. Formula is AB dot CD bar is equal to ABCD minus AB. By after the bar how many digits are, under the bar how many digits are there? 2. So we should write 2 9s. So A B C D means 1036. Full value should write minus AB. A value is 1, B value is 0. So minus 10. 1036 minus 10 is 1026 by 99 divided by 9 table. 9 11s are 99. 9 114s are 1026. So your simplest form is 114 by 11. P value is how much? 114. Q value is 11. P plus Q is 114 plus 11 is 125. So now what we discussed so far about rational numbers, just a brief explanation. First is definition. Rational number will be in the form of p by q. P, q belongs to integer set. Q not equal to 0. These are the two conditions of a rational number. Once again, p by q is a rational number. P comma q belongs to integers and q not equal to 0. After that, we have followed 4 binary operation: addition, subtraction, multiplication, division properties. Addition property will satisfy all the properties: closure, a plus b belongs to q, commutative, associative, identity and inverse. So in addition we don't have any problem, all the properties will satisfy. When it comes to subtraction, a minus b belongs to q, the first closure property will satisfy, commutative and associative will not satisfy. Third one is multiplication. In multiplication also closure, commutative, associative, multiplication by 1, multiplicative inverse, multiplication of 0. All the 6 properties will satisfy multiplication also. Again last one, when it comes to division, only closure will satisfy. A divided by B belongs to Q. Commutative associative will not satisfy. Now next comes to the important division rules. A by 0 is equal to not defined. Any number divided by 0 is not defined. 0 by something is 0. Any number divided by 1 will get the same number. Any number divided by minus 1 will get minus of that number. So these are the 4 division rules. A by 0 is not defined. 0 by A is 0. A by 1 is A by minus 1 is minus A. Next comes to pure non-terminating decimal. Non-terminating means it will continuously repeat. So after decimal we have 2 digits are repeating. Bar indicates number of times it's repeat. So after decimal we have 2 values. So these 2 values are repeating continuously. So formula is ABCD minus before decimal AB by 99. This 99 is coming from after decimal. We have 2 digits under the bar. For each digit 1 9. Here 2 digits are there, so 2 nines. If 3 digits are there, 3 nines. So formula will change for every problem. So now next one is mixed non-terminating. AB dot CDE bar. Here after decimal all values will not repeat. So here how many numbers are repeating? 2 numbers. So repeating numbers write 2 nines. The number which is not repeating write 0. Here also numerator full write ABCDE minus ABC. So this is a mixed non-terminating decimal.